All right, so I have the session recorded. So we'll just continue. Now, today I will talk about the potential energy calculation. So we are done with kinetic. Potential energy, PE, equals to mgh. Now, for example, if I have an object placed on a table that is at a certain height from the ground, let's say it's 3 meters, and having a mass of 2 kg. And the question asks, okay, how much potential energy does the object possess? So you can calculate PE equals to mgh, so mass 2 kg times, what is the G? The G is what?
Gravitational field strength.
Yes, the G is gravitational field strength. So the 10 Newton/kg. It is a fixed number. So you always use 10 as long as you are on the earth. Okay, this is like the strength of the gravitational field of the earth.
So it means that teacher got in some question it will give us the it will not straight away give us the gravitational field strength, so we need to count it, is it?
Yes,
We
correct.
take the Newton over the kg of it.
The Newton over the kg, yeah, that is the unit.
And then we found the gravitational field.
Yes.
And then we just do the...
Okay, I'll show one example when we need to calculate the G.
Yeah.
Here, because when you have a formula, right, not only you will be asked to calculate just one, like PE, you just need to calculate PE, no. And as you may have already know, when you do the questions, you realize that always they want to ask everything. They ask the PE, they ask to find the M, they ask to find the G, they ask to find the H. So as long as whatever that you want to find, the rest has to be given. So if you want to find the M, you want to make sure the PE, the G, and the H, they are all given. Because you only have one unknown left. Is G the gravitational field? Yes, Russell. Correct. 10, okay? 10 Newton/kg. So to calculate the potential energy of this object, we take 2 kg times 10 and times the height, because gravitational potential energy depends on the height, right? Remember, if the higher you are, the greater it is. So if you can see in this formula, if your height value is very large, then your PE will be very large as well. Okay, so times 3 equals to 2 times 3 times 10, 60. Unit is PE, right? You are finding the PE. So joule is energy. KE and PE, they have the same unit, 60 joule. Now, let's say I drop the box. I drop the box and now it is on the ground.
0.
E. When I drop 0, okay, now when I put in the formula, PE equals to mgh equals to 2 times 10 times 0. Yes, because when it's on the ground, there's no more height. Okay, so this whole thing becomes 0 joule, no potential energy. Okay, if I place another object at the same height, 3 meters, but this object is heavier, 10 kg. Will it affect the potential energy of the object? Yes.
Yes.
Because there's mass in the equation, right? So PE mgh
10 times 10
times 10 times
300.
300. Much larger than this one, 60, 300. If you increase the mass or if you increase the height, both will increase the potential energy. What about kinetic energy? Kinetic energy is KE half mv square, right?
MV.
So kinetic energy depends on two things also. You can see from here, it depends on the m, and it also depends on the v. Yes. So if you increase the mass or you increase the speed, the kinetic energy will increase. And you can see the speed has a square, right? If I increase a little bit, after you square it, it becomes a bigger number. That will further increase the kinetic energy. That means kinetic energy is like hugely dependent on the v, the speed. Okay, a small increase in the speed, let's say increase by 5. When you put it in the equation, you square it, 5 become 25. Okay, it will cause a greater increase in the kinetic energy. Right. So that is the two calculations. Now, for example, if they ask to calculate, okay, Lucas is here. If they ask to calculate the mass, okay, for example, that they say, okay, one object here with a mass m having a potential energy of 300 joule. Okay, and then it is at a height of 5 meters. Calculate the mass of the object. So we do, okay, you need the triangle here. PE, MGH. We are finding the M. So cover up this one, write it at the left-hand side.
So it goes to 300 over
PE over GH.
10 times 5. It goes to 300 over 50.
Yes, 300 over 10 times 5. How do you calculate this? Can I take 300 divided by 10 first?
No.
Oh, you do the bottom
first.
Yes, 10 times 5 first. 10 times 5, because 300 is dividing these two together. So you do 300, 10 times 5, 50, equals to 6 kg. Okay, so if they ask for the G, the same thing. You get the value that you have, then you find the value that you want to find. Okay, now I'll send you a short practice on the gravitational potential energy.
Need to print it out?
Up to you. I'm sending it in Telegram, Russell. All the documents I will send in the Telegram. Okay, so the Telegram will be our main. The link I will always send in the Telegram, but because just now there was a problem, so I'll just send it in WhatsApp. So our main group is the Telegram group. Okay, so how many questions we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. About 12 questions. Okay, you try it out in class right here so that any question you can ask. You see the on top, you see this GFS. What is this GFS? Gravitational field strength. Okay, so the 10, this is the G value.
Teacher, for question A,
Right? Okay.
he said calculate the GFS, but it did not give us the
GPE, right?
gravitational potential energy.
8 is
GPE.
GPE, right? Yeah.
GPE is what? The
Potential energy.
gravitational.
Yeah. Okay. GPE is potential energy. Is the gravitational potential energy. Sometimes we just call it potential energy. But here in this document, you see a lot of GPE is the same as the potential energy.
Teacher, is it all of the number take the SI unit?
Yes, correct.
So means that some means that in height we use meter,
Yes.
in mass we use kg.
Yes. So if it's not in SI, you have to change it.
Teacher, is like no matter where how the like the sequence is it? I also can put height times mass times gravitational field strength, right?
Height times mass times. Yeah, there's the sequence doesn't matter.
Teacher, for question G,
Right.
uh, is it how do we calculate the kinetic energy of the total?
An elastic band with a mass is flicked through the air. Okay. At first, what is the energy when you stretch it?
Oh, is there a repeat?
Yeah, what is that? The rubber band one, the stretching. Elastic,
Elastic potential energy.
Yes, elastic potential energy. Now, when I flick the object, and then the object now it goes up, moving. Now I get what energy? From elastic to
Kinetic.
kinetic. Okay, to kinetic energy. And then let's say the object is moving, is going up, right? From kinetic energy is going up and up to a certain height before it drops. This is the maximum height.
At the top.
So at the top, what energy do you get at the top?
Potential.
Potential. What about the kinetic at the top?
Zero.
Zero,
Minimum.
yes. Why the kinetic at the top is zero? Because
the object is stopped.
yes, the object is stopped just temporarily before going down backwards, right? So that means you are calculating, to calculate the kinetic energy, you can calculate the potential
I just
energy.
calculate the potential energy and then it's the same.
Correct, because kinetic is converted
It
to
will be the mass. At the bottom part, at the like almost touch the ground, the kinetic energy will be max.
correct. Yes. So it's kind of like you go from KE convert to PE like this. Okay, now for the rest, for question 8. Okay, if you're not sure, question 8, look here. We look at 2 stages when the object leaves the rubber band. Okay, leaves the rubber band. The rubber band is used to launch the object high. Okay, so the moment when it leaves the rubber band, the speed is maximum speed. It is moving the fastest because as it travels upward, the speed slowly reduces, right? At some point, eventually the speed is 0 and it has to reverse. That's why the maximum speed is when the object leaves the rubber band. Okay, so we will say that this is the kinetic energy maximum. Okay, huh? Now, as the object travels up, okay, and then up to here, before it reverses down, at this point, if you only take this particular instant, what is the speed? The speed is 0. Speed is 0. And if speed is 0, that means the kinetic energy is 0. Where did the kinetic energy go? If the bottom is maximum, but up here is 0, where did the kinetic energy go? It has been transformed to potential energy. So now your potential energy is at the maximum. How much is your kinetic energy at the bottom? If your kinetic energy at the bottom is 100 joule, at the top, your potential energy will also be 100 because the kinetic energy has been transferred to potential energy as the ball moves up. All right. So that means this height, now the ball is up here, right? It is at a certain height above the ground. It must have some amount of potential energy, and that is equal to the kinetic. So that means for question G, they ask you to calculate the total kinetic energy. You can actually calculate the potential energy because you know that they are the same. At the bottom, the kinetic energy at the bottom is the same as the potential energy at the top. Okay, let me write it down here. Now you copy this in your note. Let me put 2 points. Point A, point B.
Teacher.
Yes.
Then in question 2, how to do?
Wait. Later I come back to you. Let me write it down.
You write it down first?
Yeah. Yes, for question G, Russell, correct. If you find the potential energy, that will be the same as the kinetic energy. Because you know that the kinetic eventually transferred to potential. If you take halfway, if you look at the diagram just now here, if I take halfway, what is the PE? 50%, right? So it will be, let's say 50 joule. Because up down here is 100, right? Here is 50. What about the KE? Also 50. They share half, 50-50, because it is halfway there. But at the top, it will be all PE. At the bottom, it will be all KE. Okay. That is for Lucas. Okay. Now everybody look here. This will be in your test. Before we end, before I let you go, let me finish this. Very short one. Okay, about the conservation of energy. When I drop the ball, what is we are going to look at all the energy at each point. Okay, so let's say I drop the ball like this and it falls down here before it touches the ground. Okay, imagine that this is the ground. You let the ball fall just when it touches the ground. Okay, very, very close to the ground, but not yet touch. We are going to take this point as A and this point as B. Okay, let me write it here. Before touches. Okay, this is start falling here. Now, at point A, what is the PE? Let's say we take the total energy is 200 joule. Okay, so if up here is 200 joule, then our KE is 0 joule because it's not moving yet. Right? Huh? Now, halfway, point C. What is the PE? The PE is half. Okay, so 100 joule, the KE is also half, 50-50. Because at point C, it already started moving, and so that it has kinetic energy, and also it is at a certain height from the ground. Okay, what is the height? Half of it. So still there is potential energy, half already. Right, so 100 and 100. Now at point B at the bottom, what is the potential energy? This one, because it's very, very close to the ground, so we would just assume that it is at the ground. So the PE we would say 0. Because the value is so small, we just take 0. Okay, so for anything that is very close to the ground, the PE is 0. What about the KE? If the PE is 0, and then the KE would be at the maximum because it has fallen from up there, down there. At the bottom, point B, the speed will be the largest. So KE is maximum how much? This one is 200. Now, notice that all here must add up to 200 joule. What is this? Total 200 joule. Right? What is this? Total 200 joules. The total energy at each point. When I say total, that means the PE plus the KE together. Okay? The total energy at each point must be the same. 200, 200, 200, 200. This one you need to remember. Okay? So let me write it here. Total energy at each point must be the same. This is based on what? This is based on the conservation of energy. So let's say if the question asks you, point D, the ball at point D has a kinetic energy of 45. Then the question asks you to find, okay, what is the potential energy? Then using this concept, because you know that the total must be the same at every point, so point D is the same. So K is 45. How do you find the PE? You use 200 minus the 45, right? So you get 155. Again, these two add up equals to 200. Question asks you, point E, the kinetic energy, how much if the potential energy is, let's say, 25? So how do you find this? Again, you use 200 minus 25. So you get 175. Again, this add up to 200 joules. Okay, so during the fall, it has to obey this principle. Okay, it has to obey or fulfill the principle of conservation of energy, which says that the total energy cannot be different, cannot change. Now, why we say that from A to B before it touches the ground? Because if the ball touches the ground, what energy you get out of it by hitting the ground? You get sound, you get heat, right? Because when it hit the ground, there's friction. There's friction, there's sound produced. So that means from this 200 joule, some of the energy will go to heat, some will go to sound. Okay, so if you consider the ball hitting the ground after hit, can we say after hitting the ground, what do you get? You get heat energy, you get sound energy. Still, you have some kinetic energy left. Okay, so maybe this one, total is 200, right? So maybe you have 100 left. Where is the other 100? Okay, 60 go here, 40 go here. So this two energy, because the remaining is only 100, right, for the kinetic energy, the rest has been transferred to heat and sound. So heat is a waste energy. We would say that these two energy is wasted. Is wasted. So when the ball rebound, how much kinetic energy now it has? After it strike, right, just when it starts rebound, 100 joule. Your PE is 0, because just when it starts rebounding, it is still very close to the ground. So PE will still be 0, but you notice that the KE now comes down to 100. The total energy here become 100, no longer 200, because when it hit the ground, some goes to heat and sound and wasted. You cannot recover it anymore. Okay, so that is why you see the conservation of energy, okay, this one, we would take when you start falling to the point before you hit the ground. That is when it's the same here, 200, 200, 200, 200, 200. Okay, and sometimes the question will ask, okay, when the ball hit the ground, what energy produce? Then you mention heat energy, sound energy, okay, like this. All right, take note of this, and I will let you go. I'll see you again next Tuesday. Okay, so after you finish, then you can go.
Teacher, can you explain the part where the ball bounces?
The ball rebounds.
Yeah.
Okay, so before we take two situations like this. This is when the ball almost hit the ground. This is the right one. And then on the left is when the ball start rebounding like this. Okay, let's look at the PE first. The PE is 0 at both conditions. both situation, PE 0, PE 0, because both are very close to the ground. Okay, so what about the KE? This KE here is 200. Okay, 200, but when it hit the ground, you get heat energy, you get sound energy, right? That means some energy goes to heat, some energy goes to sound. So maybe this one is, okay, 30. Maybe this one is 50, just an example. Okay, so that means when the ball rebound, now it has less energy because 30 already go to heat, 50 already go to sound when it hits the ground, right? So what is the kinetic energy here? The kinetic energy when it started rebounding is, you take 200 minus 50 and minus 30, so it's 120 joule. Okay, so comparing the kinetic energy here, 200, this one is 120, so 80 is lost to heat and sound. This is what is happening when during the rebound. Some energy is lost to the surrounding. It's because of the heat and sound. That is why every time it rebounds, you see the ball goes like, it goes achieve lower height. It cannot achieve the same height as before, right? You drop it from 9 meters. It cannot rebound back to 9 meters. It rebound back to maybe 4 meters. The second rebound, it rebound to maybe 2 meters. The third rebound, 1 meter. Because each rebound, it is losing energy. To where? To heat and sound when during the strike. Okay? Should I finish writing? May I leave? Yeah, if you finish, you can leave. Okay, so after you rebound 120, right? So when the ball comes back to the height, the PE is 120. Comparing the first instant you drop it is 200. After the rebound, the PE maximum is 120. Already decreased. So each rebound, it gets smaller and smaller and smaller, and eventually no more. And the ball comes to rest. Okay, after a few rebound, then it will stop bouncing. Okay, Ivan.
Yep.
All right.